Welcome back to Smith Coding and Design. In the previous tutorial, we went over a 3D adaptive clearing operation where we went in and cleaned up inside of the channels around the upper portion of the ashtray where our 3/8 int mill could not fit. And then we went ahead and did a 2D contour where we just cleaned up the sidewalls in those channels. Today we're going to go ahead and get into a 2D pocketing operation where we go ahead and create the outline of our Pokeball to prepare for our epoxy pour. Okay, so now we're going to go to 2D and we're going to do a pocketing operation. I'm going to go to Tools and I'm going to my Tormach library. I'm going to select the Char's 1/8 2 flute end mill. All right, click OK. So there are a couple things I'm worried about with this toolpath. So the primary source of concern is my tool is long and skinny. Right, it's 1/8 inch diameter and the flute length is 750 thousandths, and we need that long flute length so we can get over the sidewalls of the ashtray and then remove material from the outline of the Pokeball. So there are two problems with that. One, I'm worried about deflection, so if I move too fast we can end up with deflection issues, and two, if I were to try to take off too much material, I'm afraid that I could break the end mill. So for our speeds and feeds, we're going to be at 7,000 RPM. We're going to be moving quite slow at 15 inches per minute. And our feed per tooth is right at 1,000ths. Okay, so now we'll get into geometry. We're going to select the upper and lower portion of the Pokeball as well as the outline. All right. So now we'll get into our heights. We've already removed all of the material from the top of our Pokeball. So I'm going to set this to Model Top. I'm then going to go to the Passes tab. The first thing I'm going to change is the maximum step over. I'm going to make that 50% the diameter of the end mill. I'm going to enable finishing passes, and I want my finishing pass to be at a 10,000th step over. I do not want to leave any stock. However, I do want to go in multiple depths, right? I don't want to try to slot the outline in one pass and break my end mill. So I'm going to change my maximum step down to 30 thousandths. Okay. And then I'm going to enable smoothing and feed optimization. Compensation type in computer is fine. I'm not worried about walking in any sort of tolerances. I'm just going to fill the Pokeball with epoxy resin. I'll now go to the linking tab and I will change my lead and sweep angle to 45 degrees. And I will press OK. All right, so Fusion generated the toolpath rather quickly, but you'll notice we have a major problem. Our estimated time is 2 hours, 48 minutes, and 21 seconds, which is insane. So we need to fix this. This is a good learning opportunity. And if we examine closely, we see that the issue is we are cutting a lot of air, and that's because we chose our top height to be model top. So what I'm actually going to do is, if we look at our stock left from our previous operation, you'll notice that the upper and lower part of the Pokeball have already been roughed out, but the outline has not. So what I'm going to do is split this pocketing operation into two toolpaths. So I'm going to right click and then I'm going to go to duplicate. And what we're going to do is make two separate toolpaths to take advantage of the fact that we already roughed part of the Pokeball. So the first thing I'm going to do is open up the first pocket, and we are going to go to our geometry. We're going to clear our geometry, and we're only going to select the upper and lower halves of the Pokeball. And then we're going to go to our heights tab, and here's where we fix the issue where we were cutting all that air. Instead of our top height being model top, I'm going to go to selection, and then I'm just going to select the floor of either half of the Pokeball. The next thing I'm going to do is go to linking, and we can save some time by changing our ramp clearance height from 100 thousandths to 20 thousandths. That just means we start 20 thousandths above our stock as we helical into the pocket. And now I'm going to click OK. And you'll notice our toolpath is now 4 minutes and 32 seconds, which is much better, orders of magnitude better than 2 hours and 48 minutes. So now what we'll do is go into our second pocket. So this is just a duplicate of the first. We're going to do the same thing. We're going to go to geometry. We're going to clear our geometry. However, this time we are going to select the outline of the Pokeball. And then in geometry, instead of model top for our top height, we're going to go to selection. And remember, the outline has not been roughed. It is basically solid. There's been no material removal. So I'm just going to select, one of the upper surfaces. And then we will again go to linking, and we will change our ramp clearance height from 100 thousandths down to 20 thousandths. Press OK. And that should do it for our two pocketing operations. And we go from, again, 4 hours down to roughly, we'll call it 19 minutes if we were to add both of these tool paths together. So that is far superior than what we originally had. So now what we need to do is just go ahead and simulate each of these tool paths, right? We changed our top heights. We want to make sure we don't collide with the side walls or any of our fixturing. That could damage our machine or break a tool. So let me zoom out a little bit. So you'll see we just went right in, did a small helical entry that should be around 20 thousandths above our pocket. And then we just start clearing our pocket, and we do that for both halves of the Pokeball. We'll speed it up so we can get through the simulation. Perfect. We ran into no collisions. Everything looks good. And now we'll simulate the second pocket. And again, should be along the same lines. We should perform a helical entry and then just start clearing away the material. And this time we're going in steps of 30 thousandths, just so we don't take off more than our end mill can handle, break the tool, or run into any sort of deflection issues. All right, so this one takes a little longer. I'll go ahead and speed it up. And that does it for our pocketing operation. We now have the outline of our Pokeball. The last thing we need to do to finish up Op 1 is go ahead and chamfer around the top of our ashtray. So I'm going to go to 2D chamfer, go to the tool selection, go to my Tormach library, and I'm going to select a 1/4 inch chamfer mill. Select OK. We're running at 4,000 RPM, 20 inches per minute. That gives us right around 1.25 thou per tooth. For the geometry, we're just going to select all of the contours around the upper portion of the ashtray. Okay, and now we'll go into our heights tab. And instead of stock top, again, I'm going to choose model top because all of the material has been removed from the top of our ashtray. I'll now go into the passes tab, and I want the chamfer width to be 15 thousandths. All right, and our chamfer tip offset, we'll leave that to default to 40 thousandths. So again, the tip of the chamfer mill is fragile, especially if it comes to a sharp point. So we want to make sure that we move the tool away from the tip of the chamfer. That way we don't run into any issues where we break the tip off and ruin our end mill. So that's fine. I'll go to smoothing and feed optimization, linking in, again, 45 for the lead in sweep angle. I'll click OK. And we will simulate. This is probably going to go rather quickly, so I will slow it down. That way we can see what's happening. We enter in, and again, we just chamfer around those top edges. And now another thing we could do is you notice that we enter in the back of the ashtray. So for some people, they may want to change where the tool enters. Maybe they don't like the chamfer mill entering in the back where they can't see it. So what we'll do is we can right click and edit the tool path. And then if we go back to linking, we can select an entry position and say I want to start here in the front where I can see it. So we'll just go ahead and click there. And now Fusion will regenerate the tool path. And if we simulate, you'll notice we start at the front of the ashtray instead of the back. So if we were worried about a tight clearance window, we wanted to make sure that our toolpath was running fine, we weren't going to break our end mill, we can move it to the front just for that reason. So we'll go ahead and we'll simulate again just so we can see that. We'll slow it down and you'll see that our tool does indeed enter at the front of the ashtray, and then we'll speed it up so we can see that it goes and it performs the same tool path that we had before finishing all those chamfers. All right, so that does it for Op 1. We'll now get into the machining on the Tormach, and then in the next video we'll go over how I went in and I cleaned up the inside of the ashtray after I poured the epoxy resin. Thanks for tuning in. Alright, so now we begin our 2D pocketing operation, where we are on the upper and lower pockets of the Pokeball. Again, using the smaller 1/8 inch end mill, we're going nice and slow at 15 inches per minute. And in terms of the pockets, the upper and lower portion of the Pokeball have already been roughed out, so we are just removing the 10 thousandths worth of stock that is on the bottom. Alright, so now we perform the second part, or the second pocket, where we are just going in and clearing the material away from the outline of the Pokeball. And so we're still moving slow at 15 inches per minute. However, the outline of the Pokeball was solid. There was no material removed from previous operations, so our depth of cut is 30 thousandths. And again, we're just taking it nice and slow to try not to break the end mill. Alright, so now we finish with our 2D chamfer operation, where we're just breaking the edge, making sure that nothing is sharp and there are no burrs that could injure somebody if they were to pick up the ashtray. So that does it for this tutorial. Please tune in to the next tutorial, where we will clean up the inside after the epoxy pour. Please like and subscribe, and I'll catch you next time.